Okay, let's do another example for related rates. We have a 5 meter ladder which is leaning against a tall wall. The bottom of the ladder starts sliding away from the wall with the constant speed of 0.6 meter per second. At what speed the top of the ladder falls when it is 3 meter above the ground? Well, to start doing the modeling, we always know that the first step is identifying the quantities involved in the problem. Yes, it's better for this problem to draw the picture from the beginning, and you see that okay, this is my ladder up there, and it is 5 meter long, and then this is, well, this is a wall, so it means that it will form a right angle there. What happens is that the bottom starts moving away. As a result, the top will move down. And when you look carefully, the distance of the bottom of the ladder from the wall and the distance of the top from the ground are two variables that are involved in this question. So we have the distance of bottom of the ladder from the wall, and the other one is the distance of the top from the ground. So we have to choose a notation for this one. Well, let me put this one as x and that one as y. So this, we are going to use x and y for this, and then try to translate all the given information and write them in terms of these variables. For example, we are looking for what is the speed at which the top of the ladder falls. So we are looking for dy dt. Well, what else? We know that the bottom is moving away with the speed of 0.6 meter per second. That is rate of change of x. And well, we know we are interested in finding this at the moment that the top of the ladder is 3 meter above the ground. So it means that y is equal to 3. And when you see this here, since we have a right triangle, we know what is the hypotenuse is 5. The y, the height will be 3, and well, do the Pythagorean theorem, and then that will give you 4 for here. So x is root of 5 squared minus 3 squared, which is 4. So we have that one too, and well, these are the information given in terms of these variables. Now move to the second important thing. What is the relation between these two? So write the equation relating the variables. The variables are related through the Pythagorean theorem. So it will be just x squared plus y squared is equal to 5 squared, which is 25. And that's the equation. That's the main equation, and that's the only equation you need to know. Now, our mathematical problem is ready. So we are looking for dy dt when when x squared plus y squared is equal to 25, and dx dt is 0.6, and y is 3, x is 4. So all these information. So we have a very, just forget everything about ladder, everything up there is gone. Now we have a mathematical problem. To solve that one, we need to differentiate the equation with respect to time, and use the chain rule. Yes, that's use the chain rule. So this means that we have to differentiate x squared plus y squared equals to 25. Well, the chain rule applied here will give us 2 dx dt x to the power 2 minus 1 plus 2 dy dt y to the power 2 minus 1 is equal to 0. We can simplify a little bit here, but let me just go ahead and apply the second step, which is plug in the given values. So here 2 times dx dt is 3. Oh no, dx dt is how fast the bottom moves away, which is 0.6. X is 4, and plus 2 times dy dt we don't know, and y at that moment is 3. Well, now we have an equation for dy dt. Solve it for that. Well, this gives us a dy dt, 6 of that is equal to minus 4.8. And then divide that, dy dt is going to be minus 0.8. So this is meter per second. So this is how fast the top of the ladder will move down, and the negative sign shows that the ladder is moving down. Actually, it's just getting smaller and smaller. That's the meaning of that negative sign. But steps are as before. Two main things. You had the modeling thing. Here we did the modeling, and then we solved the mathematical problem that we had in this case.